2x squared minus x, I'm checking, yes. And y equals x squared plus x. Okay, perfect. Okay. Again, we have to look at two quadratic functions. I will start by graphing this because that's the easiest. It's x times x plus 1. So if you remember how to determine the vertex, it's negative b over 2a, but it has to be right between the two x values. So when you set this equal to 0, you will get x equals 1. I'm going to use a bigger unit, x equals 0 and x equals 1. So there is no question that the axis of symmetry will be right in the middle, and it must be x equals 1/2 because it has to be in the middle between 0 and 1. But I don't know how high. I do know that the function has a minimum. How do I know? Because a, the leading coefficient, is 1, greater than 0. A is 1. Every time it's greater than 0, the function looks like this. The quadratic function has a minimum. So all I have to do is just plug in 1/2 in the function. So 1/4 plus 1/2 is 3/4. So right? So negative b, just checking my numbers, 1. Sorry. I wasn't getting what I was supposed to get. So the solutions are x equals 1, x equals negative 1, and x equals 0, not 1 and 0. So therefore, the axis of symmetry is negative b over 2a, so negative 1/2. Okay, so when I plug in negative 1/2, I have 1/4 minus 1/2, which is negative 1/4. So this is the point. The vertex is negative 1/2, negative 1/4. Let me write it on the side for you. So I have negative 1/2 squared and minus 1/2. So this is 1/4 minus 1/2, which is negative 1/4. Okay, so then I know how this function looks like. The other one, so this is y equals x squared plus x. The other one needs a little bit more work, and it has to be as symmetric as possible. My graph is not perfect. Good, so let's determine the x and y intercepts for the other one. So I'm looking at 2x squared minus x minus 3 and set that equal to 0. And let's see, is this factorable? Yes, it is. How do I factor it? 2x plus 1 and x minus 3. I'm checking my numbers now. 2x squared, no. 2x. So 2x minus 3, 2x plus 3. Is that what I want? And x minus 1. I'm checking my numbers. 2x squared. Yes. Minus, right? 2x minus 3 and x plus 1. If you try to guess, I don't like the guessing method, but if I try to guess, I have to check. So 2x squared plus 2 minus 3, that's correct, minus 3. Good. So x equals 3/2 and x equals negative 1. I don't need this one. Good. So then we have x equals 3/2 and x equals negative 1. Now I also have to find the vertex. And remember the vertex, the coordinates of the vertex, negative b over 2a. Negative b is negative 1. 2 times a is 4. So this is 1/4. And I have to plug in 1/4. 2 times 1 over 16 minus 1 over 4 minus 3. All these calculations are necessary to graph. So this is 1 over 8 minus 1 over 4 minus 3. The least common denominator is 8, 2, and 8. 1 minus 2 minus 24. So negative 25 over 8. Okay, still a minimum. I'm going back to my graph. So it crosses at negative 1, like the other one does, and also at 3/2. So this is 1, this is 2, this is 3/2. And it crosses here, and it crosses here. It has a minimum. It has a minimum. The vertex, where are you, my vertex? 1/4, okay? So the axis of symmetry is at 1/4. And this distance has to equal this distance. If it doesn't, I have an error. So let me see. So this is 1 and 1/4, and this was 1 and 1/4. 1. So it was 3/2. 3/2, 1.5. Yes, perfect. Okay, so now the minimum is a little bit lower than negative 3. So 1, 2, 3, right here. So here's the graph of the other parabola. And you can say, where are they crossing? I don't know. But I'm assuming that at some point in time, they will be crossing here. We'll see in a moment if they do. This is the area in question. It's a very good problem you picked. Very good. I have to determine the points of intersection. Without the points of intersection, I don't know where the area in question is. Okay. So I'm assuming that this will cross. I can graph them with a calculator and see if, if there is any discrepancy, but I don't see any problem. Let's find the points of intersection. So again, I'm setting these two equal to each other. So 2x squared minus x minus 3 will equal x squared plus x. Okay, so then I have x squared minus 2x and minus 3 equals 0. This is an easy one, x minus 3 and x plus 1. So I get that x equals 3 and x equals negative 1. So this is right above, further to the right, so right above 3. So this is 3 comma whatever. I don't need to find the y value. And this is, which I knew already, the point of intersection here is negative 1, 0. So then the area will be the integral from negative 1 to 3. Careful now, from the function above, which is x squared plus x, minus the function below. But the below function is all this, and I have to put minus in front of it. So minus 2x squared plus x plus 3. Very good problem. Thank you for picking that. Okay, so at this point, I will simplify inside a little bit to make my life easier. Negative 1 to 3. So this is negative x squared, and it is positive 2x and plus 3 dx. From this point on is straightforward. Negative x to the third over 3 plus 2x squared over 2 plus 3x from negative 1 to 3. I plug in the top value first. 27 divided by 3 is 9 with minus in front. Plus 9. Oh, very good. Plus 9. Wonderful. Minus, careful. 1/3, because this is negative, but with minus in front will be 1/3. This is positive 1, but this will be negative 3. So these two go away. So 9 minus 1/3, and this is minus 2. And this is 7 minus 1/3. Least common denominator 3, 21 minus 1. Very good example. Thank you for that. Any questions?
So that's the
Hold on. 1 minus 3 is negative 2. See what I did? I forgot to add. So this is 11. 33 minus 2. Right? 32. Careful with my numbers. I try to finish it up. No excuse. Yes, sorry, Hersh, go ahead.
So would that be the final answer?
Yes, this is the final answer, absolute final answer of all this area. 32 divided by 3. Yes, all this. Enclosed between the two graphs. That will be the absolute final answer. So this was correct. 1 minus 3 is negative 2, but I have a minus in front, so I have to add. I would like to look at the substitution rule, but at the same time, I like to look at a word problem. And especially the average rate, the average of a function. So let's do that. I don't want to forget that. So 34 through 44. So let's find the average. Average of a function. Yeah, I'm going to pick 37, and please pick the next one. So y equals e to negative, no, I don't want to do this one because I'm going to do it in the next section. This is, it needs the substitution rule. So later, after we look at the section 4.5. So it's on 0, 1. So let's look at the average 39. F of x equals x squared plus x minus 2, and the interval is 0, 4. If we want to find the average on the interval 0, 4, we have to use the formula 1 over 4 minus 0, which is 4, the integral from 0 to 4 from x squared plus x minus 2 dx. And that will give us the average of this function on the interval 0, 4. I cannot determine the definite integral before I make sure that the function is continuous. The function is continuous everywhere. Okay, so then I'll continue finding x to the third over 3 plus x squared over 2 minus 2x from 0 to 4. I always like the integrals that start at 0 as a lower limit, because normally when I have to plug in 0, I don't have to do anything. So 1/4, so 64 over 3, and this is 16 divided by 2, and this is minus 8. I'm checking my numbers now again. So 64, that's correct. 16 divided by 2, 4, yes, these two go away. And then I have 1 over 4 times 64 over 3, and I'll simplify, and I get 16. I'm checking again. Yeah, 16 divided by 3 is the average value of this function only on the interval 0, 4. Any questions? Any questions? I will not forget to come back to this. Right after I present the substitution rule, I'll keep it here and come back to it. The last section of this chapter, the substitution rule. Before we look at that, I need to talk about indefinite integrals. The indefinite integral is f of x dx, which is the antiderivative plus a constant c. And this is a function, not a number. The indefinite integral is always a function, and it's the most general antiderivative of that function. So, for example, if we are asked to find the most general antiderivative of, give me any function. So let's write that. Any function you can think of. I want to write the function first. F of x. Any function? Okay, let's say x to the third plus 4x. And we're asked to find the indefinite integral of f of x dx, which is the integral from x cubed plus 4x dx. No limits of integration, as you notice. And this will be x to the 4 over 4 plus 4x squared over 2 plus a constant c. Yes, I have to simplify. I will write it one more time, simplified as x to the 4 over 4 plus 2x squared plus a constant c. One big difference between definite and indefinite is I can always verify the answer of a definite integral, an indefinite integral. Never for a definite one. So a few minutes ago, Hersh asked me, is this it? Is this, yes. I'm assuming that I did not make any error in the numbers, but I don't have a way of verifying unless I redo the problem. But here, I can show you it's very easy to verify. So we claim from a few minutes ago that the integral from f of x dx is this function, the integral from x to the third plus 4x dx. Our claim is that the answer is x to the 4 over 4 plus 2x squared plus c. Can I verify this? Yes. I will differentiate this side and differentiate this side. It's just that the theorem of calculus part 1 is not in your book. The derivative of the integral is just a function. And now I differentiate this. Bring down 4. I get x to the third because I simplify the 4 plus 4x. And the constant prime is 0. So they are the same. I can always, by differentiation, I can always check the result of an indefinite integral, but never, never for a definite integral. Because if I differentiate this, I will always get 0. So the indefinite integral is nice because I can always check my answer. Okay, so finally, what is the substitution rule? And I like to start with problem 6 on page 421. Okay, so the problem has a indefinite integral 2t to the 5th minus 3 multiplied by t to the 4th dt. And you could say, but that's not a big deal. just distribute, and you're going to do whatever you have done so far and find the function. True. That's correct. But let's suppose we want to use a substitution. And in certain situations, for example, if I change the problem and put here power 10, I won't be able to do that. I won't be able to take this to the 10th power. It will take me a while. And then distribute t to the 4th, and then find the indefinite integral. It will take a significant amount of time. And actually, I want to change it into power 10. So it's no longer this. Okay, so I put a power in there, and I know I can no longer distribute. I notice one thing, that this is a problem for me because of the power. I'm going to say give me any letter but t, any letter you would like to use.
X.
X is good, but X is normally, so let's make it so it sounds like a function. Let's say either y or u. X is good, but u. Okay, let u be this expression, 2t to the 5th minus 3. This is a new function that I just created. I need to find its differential. That's why in this example, I was kindly asking you to remember what the differential of a function is. It's not the derivative. It's the derivative multiplied by dx. If it has x, it's dx. If it has t, it's dt. So at this point,